Hello everyone and welcome to our course Theory of Programming Languages. My name is Sanzia Sultana and I will be teaching this course for this semester. Um, if you are already familiar with using Moodle, you will find all the course related topics and you will find syllabus of this course in Moodle. All the As this class is online asynchronous, every week the recorded lecture will be posted and you will find it and you can watch it through this YouTube URL link. You will find discussion forum for every week. You can post every week's question if you have any question or concern related to that week's topic, and you will find the PowerPoint presentation file also near that, next to the lecture URL link. So besides that, if you have any kind of question or concern, you can always email me, and I will appreciate if you wait for my reply, because I would try my best to reply to you as soon as I can. Other than that, I have my office hours on Fridays. You are welcome to join or email me to have a meeting. But if there is something important which is related to an assignment or like midterm or final or any kind of work, you can always email me and we can set up another Zoom meeting. uh, so so feel free to reach out to me anytime. Now let's start our topic. Our today's topic is introduction to the major programming languages. Now we'll go through this is an exciting topic. We'll learn about programming languages, which are the foundation of everything we interact with in digital world. So from websites and webs to complex algorithms powering artificial intelligence, my goal today is to give you an understanding of the evolution, like types and applications of these languages, as well as their role in modern software development. To start, programming languages are formal languages comparing instructions used to communicate with computers. They allow us to solve problems and build software. While some languages are designed for specific tasks, others are general purpose, giving developers the tools to tackle almost any problem. So here is the overview. We'll learn why programming languages are important, how they impact software development, and low level and versus high level languages. So if we talk about the history, programming languages have come a long way. The journey began with machine code in the 90s 40s. So it evolved into assembly language first and later saw the creation of structured and object oriented languages like C and Java. Today we have versatile tools like Python, which can be used for everything from web development to artificial intelligence. Okay, so here let's take a closer look at the evolution of programming languages. This journey showcases how we have progressed from simple binary instructions to highly sophisticated and human readable languages that power today's complex applications. So first we had machine language, like binary code. So as I said, programming began with machine language, the first generation of languages. These instructions were written in binary code, combinations of zeros and ones that the computer's hardware could directly execute. While efficient for machine, writing and debugging code at this level was highly error prone and time consuming for humans. Then we had assembly language, like symbolic code. To simplify programming, assembly languages were introduced. These are symbolic representations of machine code using mnemonics instead of binary numbers. For example, instead of writing 0101, programmers could use commands like add or sub. So assemblers converted these symbolic codes into machine readable instructions, marking a significant leap in usability. Then we had high level languages, human readable. So the introduction of high level languages transformed programming. Like these languages such as C, Python and Java are closer to human language, making them much easier to read, write and maintain. So, high level languages abstract away the details of the hardware, enabling developers to focus on solving problems rather than managing machine specific details. Fourth is modern trends in programming paradigms. So, as the need for more efficient and scalable solutions grew, um, modern paradigms such as functional programming, declarative programming, and hybrid approaches gained popularity. Um, so, uh, like uh, Functional languages like Haskell emphasize immutability and pure functions, while declarative languages like SQL allow developers to describe what needs to be done rather than how to do it. Hybrid languages like Scala combined features from multiple paradigms. Now, the key milestones in this evolution include the creation of Fortran in the 1950s, which was the first high level programming language used to scientific calculations, and COBOL, um, designed for business applications. These languages laid the groundwork for today's versatile programming tools. So, modern languages like Python, JavaScript, and Swift continue to push the boundaries of what's possible, driving innovation across industries. Okay, let's dive into the major paradigms of programming. These paradigms represent different ways of thinking about and organizing code, each with unique strength and purposes. First is procedural programming. Um, Procedural programming is one of the most fundamental paradigms, focusing on procedures or routines to perform tasks. It organizes code into blocks or functions, each designed to carry out specific tasks. A well known example is the C programming language. For instance, in C, you might write a function to calculate the sum of numbers and then call the function whenever needed. This paradigm is highly efficient for straightforward step by step problem solving. Second is object oriented programming. So, as you already familiar with object oriented programming, which revolves around objects, self contained units that combine data and methods. It's based on four main principles: encapsulation, inheritance, abstraction, and polymorphism. So, languages like Java and Python are widely used in object oriented programming, and this paradigm is ideal for creating modular, reusable code. For example, in Java, you can define a car class with attributes like color and speed and methods like drive or stop. You can then create multiple objects, cars, with unique characteristics. So, third is functional programming. Functional programming focuses on using pure functions and avoiding shared state or mutable data. It emphasizes immutability and side effect free computations, making it ideal for parallel processing and mathematical computations. Languages like Haskell or Scala are popular in this paradigm. For example, in Haskell, you write concise functions to process data without altering its original state, which simplifies debugging and improves reliability. Okay, fourth is scripting languages. Scripting languages simplify tasks and are often used for automating repetitive tasks or enabling interactively on web pages. They are generally interpreted, making them fast to prototype with. So, examples are like JavaScript, which powers dynamic web content, and PHP, often used in back-end web development. These languages allow for rapid development and are commonly used in web environments. Okay. Fifth is declarative programming. In declarative programming, you specify what needs to be done rather than how to do it. This paradigm abstracts away the implementation details, focusing on the desired outcome. So, SQL is a prime example where you write queries like select all from table name to retrieve data without specifying the underlying mechanics. Another example is Prolog, widely used in artificial intelligence to declare relationships and let the interpreter figure out the logic. So, why these are important? Understanding these paradigms helps developers select the best approach for a given problem. For instance, object oriented programming might be perfect for building scalable applications, while functional programming could be better for data intensive parallel processing tasks. By knowing these paradigms, you can adopt a hybrid approach to harness the strengths of multiple paradigms in one project. Okay, in this section, we'll compare some of the most widely used programming languages. Each language has unique features and is suited for specific tasks, making them essential tools for like in the software development world. So, first is Python, which is easy syntax, versatile. Python is often celebrated for its simplicity and readability, like its straightforward syntax, which makes it an excellent choice for beginners and experienced developers alike. It is versatile. It can be used for web development, data science, artificial intelligence, and automation. Um, Frameworks like Django and Flask streamline web development, while libraries like TensorFlow and Pandas make Python a favorite in machine learning and data analytics. Second is Java. So, Java is platform independent, object oriented programming. It is a general purpose platform independent language, meaning that code written in Java can run on any device with a Java virtual machine. It's if it's written once, it can run anywhere. There is a philosophy like write once, run anywhere. This philosophy makes it a popular choice for enterprise applications. As an object oriented language, Java emphasizes reusability and scalability. And it is widely used in Android app development, enterprise systems, and back-end frameworks like Spring and Hibernate. C++, high performance and complex. C++ is known for its performance and efficiency, making it a go-to language for systems programming, game development, and applications requiring low-level memory management. However, its complexity can be a hurdle for beginners. Features like pointers, manual memory management, and extensive libraries offer powerful tools but require a steep learning curve. Okay, next is JavaScript. It is used for web scripting and it is dynamic. JavaScript is the backbone of modern web development. It enables interactively and dynamic content on websites, making it essential for creating rich user experiences. So its versatility has grown with the advent of frameworks like React, Angular, and Vue.js for front end development, as well as Node.js for server side scripting. It powers everything from simple web pages to complex single page applications. Okay, next is SQL, query databases. SQL, or structured query language, is the standard for interacting with relational databases. It allows developers to retrieve, insert, update, and delete data efficiently. SQL is not a general purpose language but a specialized tool for managing and querying databases. Um, whether you are building web applications or analyzing data, SQL is in you have to use SQL for handling structured data. So these programming languages represent a spectrum of capabilities, from Python's simplicity and versatility to C++ raw power and efficiency. The choice of language often depends on the task at hand, whether it's building a website, developing a mobile app, or managing large data sets. So understanding these differences will help you make informed decisions in your project. Now we'll learn about each of the languages more. So as I said, Python is a general purpose interpreted programming language. By general purpose, we mean that it can be used for a wide variety of applications, from web development to artificial intelligence. Being an interpreted language means Python code is executed line by line, which makes debugging easier and allows for quick prototyping. It was created by Guido van Rossum in the late 1980s and officially released in 1991 with the philosophy of prioritizing readability and reducing the complexity of programming. Now, uh, the features of Python, we can say, is it easy syntax, like Python syntax is simple and similar to plain English, like making it an excellent language for beginners. For instance, if you want to print hello world in Python, you just need to write one line, print and parentheses hello world, that's it. You don't need to add any semicolon or any kind of symbol or anything. This simplicity allows developer to focus on solving problems rather than learning complex syntax. Then second is Python has a large library support, so which provides pre-written code for common tasks such as file handling, web development, and data manipulation. Additionally, its ecosystem includes numerous third-party libraries like NumPy for numerical computations, Pandas for data analysis, and TensorFlow for machine learning. So whether you are building website, automating repetitive tasks, or developing machine learning models, Python has the tools you need. It supports multiple programming paradigms, including procedural, object-oriented, and functional programming, which allows you to choose the best approach for your project. So here we'll see what are the applications we can have, like for data scientists, due to its powerful libraries like Pandas, Matplotlib, and Seaborn, which simplifies data manipulation and visualization. So combined with machine learning tools like scikit-learn, and TensorFlow, Python enables groundbreaking research and applications in AI. For web development, With frameworks like Django and Flask, Python makes web development faster and more efficient. These frameworks handle much of the backend complexity, allowing developers to focus on creating user friendly experiences. Third is automation, it is often used for scripting and automation. Whether it's automating repetitive tasks such as file handling or web scripting to gather data from websites, Python simplifies these processes with libraries like Selenium and Beautiful Soup, this kind of libraries. Last, we have Python is at the forefront of AI development, powering applications in natural language processing, computer vision, and robotics. Libraries like TensorFlow and PyTorch make it easy to build and train neural networks. So these are the popular frameworks as I already mentioned: Django Flask for web development, TensorFlow, PyTorch for AI and machine learning, Pandas, NumPy for data analysis. Now let's shift our focus to Java, one of the most widely used programming language in the world, known for its robustness, versatility, and platform independence. Java continues to be a top choice for developers across various domains. So, it is an object oriented platform independent programming language. It was developed by Sun Microsystems and officially released in 1995. Um, Java follows the philosophy of write once, run anywhere, which means code written in Java can run on any device that has the Java virtual machine. So, this feature makes Java highly versatile and suitable to cross platform development. Its design is based on the principles of simplicity, security, and portability. So, it is built entirely on the object oriented programming paradigms, which means it organizes code into reusable objects. This makes Java code modular, flexible, and easier to maintain. Um, Key principles of object oriented programming like inheritance, encapsulation, and polymorphism are integral to Java's design. So, as I said, it is platform independent. You can write your code and run it where you have Java virtual machine. So, it is known for its strong memory management also, like exception handling and automatic garbage collection, making it robust and reliable. It also includes built-in security features like class loaders, bytecode verification, and a security manager to prevent unauthorized access. um, so it is also multi-threaded. So the multi-threading capabilities allow developers to build applications that can perform multiple tasks simultaneously. This is particularly useful for real-time systems and applications that require high performance. So some applications of Java include enterprise software, Java is the backbone of enterprise level applications. It powers frameworks like Spring and Hibernate, which are widely used for building secure, scalable, and high performance enterprise systems. Many banking, healthcare, and e-commerce applications rely on Java. Then mobile applications. Java is the primary language for Android app development. Tools like Android Studio make it easy for developers to create mobile applications, ensuring compatibility with the Android operating system. Java is also used to to use for server side web development, especially with frameworks like Java Server Faces, JSF, and serverlets. These tools enables the creation of dynamic and interactive web pages. Lastly, we can say Java is a critical language for big data technologies like Apache Hadoop and Apache Kafka, as well as for platforms like AWS and Google Cloud. So here is the Java ecosystem. Like it is one of the most extensive and well supported in the programming world, offering tools, frameworks, and platforms that make it versatile and powerful for developers. Now, let's break it down for some essential components. First is Java Virtual Machine. At the heart of Java's ecosystem is the Java Virtual Machine. The Java Virtual Machine ensures cross-platform compatibility, one of Java's greatest strength. By compiling Java code into bytecodes, JVM allows programs to run on any device or operating system where the JVM is installed. For instance, you can write a program on a Windows machine and run it on a Linux server or a Mac without changing the code. The right once run anywhere capability has made Java a dominant choice for cross platform applications. Second is frameworks. Like Java's ecosystem includes powerful frameworks that simplify and accelerate development, especially for backend application. First is Spring. Spring is a comprehensive framework used for building enterprise level applications. It offers tools for dependency injection, transaction management, and MVC architecture. Developers use Spring to create scalable, secure, and maintainable back-end system. For instance, companies like Netflix rely on Spring for microservices architecture. Next is Hibernate. Hibernate is an object or a relational mapping framework that simplifies database interactions by converting Java objects into database tables and vice versa. This eliminates the need to write complex SQL queries manually, speeding up development and reducing errors. It's widely used in applications that require robust data handling. Um, Third is development tools, IDEs. So Java developers have access to several integrated development environments like IDEs that enhance productivity and streamline coding workflows. First is Intel IDEA, which is known for its advanced code completion, debugging tools, and developer friendly interface. It's a favorite among many Java professionals for its intelligent suggestions and built in features for frameworks like Spring. Second is Eclipse. Eclipse is a highly customizable and open source IDE offering a vast library of plugins to extend functionality. It's popular in enterprise environments and supports integration with various tools and frameworks. Third is NetBeans. NetBeans is another open source IDE supported by Oracle. It simplifies Java development with features like code templates, easy project management, and built in debugging tools. So, in summary, we can say the Java ecosystem provides a robust set of tools, frameworks, and platform independent runtime environment, making it ideal for a wide variety of applications. Okay, so now we'll talk about C++. which is one of the most powerful programming languages, renowned for its performance and versatility. It serves as the backbone for many applications that require efficiency and control over hardware. Now let's see the overview of C++. So it is a high performance compiled programming language that was developed by um, Stroustrup in the 90s 80s as an extension of the C language. Um, the goal was to combine the efficiency of C with the flexibility of object oriented programming. Being a compiled language means that C++ code is converted directly into machine code, making it faster than interpreted languages like Python. This makes it ideal for performance critical applications. So the key features like that I just said, it is in high performance, it is object oriented and low level memory manipulation. So C++ is designed to deliver exceptional performance. Its compiled nature and support for direct memory manipulation make it suitable for applications where speed is critical, such as game engines and real-time systems. Then it also supports the principles of object-oriented programming, including encapsulation, inheritance, and polymorphism. These features allow developers to create modular and reusable code, which is particularly useful for large and complex projects. Then we can say it is one of the most significant advantage of C++ that it is its ability to interact directly with hardware through pointers and manual memory management, and this level of control is rarely found in other programming languages, making C++ ideal for system level programming and embedded systems. Now C++ is the preferred language for game development due to its performance and ability to manage hardware resources efficiently. Popular game engines like Unreal Engine are built using C++, enabling developers to create high performance, graphically intensive games. Second application is like it is used for developing operating systems. Its low level capabilities make it suitable for tasks that require direct interaction with hardware or real time constraints. Then other applications include simulations, financial systems, and applications requiring intensive computation, such as CAD, computer aided design software. So, C++ has maintained its relevance over decades due to its unparalleled strength in performance, flexibility, and control over hardware. So let's dive deeper into what makes C++ an enduring choice for developers working on high stakes applications. Now, first one is the performance critical systems like Unreal Engine. Like one of the C++ greatest strength is its ability to handle performance critical systems. It is widely used in developing real-time applications like Unreal Engine, one of the most popular games engines. This powers some of the most graphically intensive video games and simulations, relying on C++ for its ability to manage resources efficiently and execute tasks at lightning speed. Second is libraries for graphical user interface development. So, um, C++ offers a robust set of libraries that extend its functionality So some examples are like Boost. Boost is a collection of libraries that support tasks like multi-threading, data structures, and algorithm implementations. Then Qt. Qt is also a powerful library for building cross-platform graphical user interfaces. Developers use Qt to create visually appealing and interactive desktop and mobile applications, ranging from scientific tools to multimedia applications. Third is versatility in embedded systems. So, C++ is extensively used in embedded systems, which require direct interaction with hardware. Its low level memory manipulation capabilities combined with its performance make it ideal for devices like microcontrollers, robotics, automotive systems, and IoT devices. For example, many modern cars rely on embedded systems programmed in C++ for their infotainment and safety systems. So, why are these strengths important? Um, the combination of high performance, robust library support, and low level access to hardware makes C++ the preferred language for developers working on systems where reliability and speed are critical. Okay, now JavaScript. It is one of the core technologies of the modern web, powering interactivity and dynamic behavior on websites. So, so basically, JavaScript is an interpreted scripting language that runs in the browser and on the server with environments like Node.js. Um, it is introduced in 1995. It was originally designed to add interactivity to web pages. Over the years, JavaScript has evolved into a versatile language that can handle everything from front end development to back end server side applications. It's supported by all major browsers, making it the important and standard for web programming. So some key features of JavaScripts include like it is dynamic, um, meaning it allows developers to change the structure and behavior of web pages in real time. For example, a form on a website can provide immediate feedback to users without requiring the page to reload. It is asynchronous, means it supports asynchronous operations, allowing tasks like data fetching from servers using APIs to happen in the background without interrupting the user experience. This is commonly achieved using features like callbacks, promises, and the asynchronous wait syntax. Third is event driven. Um, it is it reacts to user actions such as clicks, keystrokes, or mouse movements. For example, when you click a button on a web page, JavaScript executes a predefined function to perform an action, like submitting a form or displaying a pop up. So basically, the main application for JavaScript is like web development. It is the JavaScript is the backbone of front end web development. It works alongside HTML and CSS to create interactive and visually appealing web pages. Frameworks like React, Angular, and Vue.js enhance its capabilities for building dynamic user interfaces. Secondly, it is like it enables animations, interactive forms, and dynamic content updates. For example, JavaScript allows for real time chat applications or live updates on a dashboard without requiring to uh, reload a page. Third is server side development. So, with environments like Node.js, JavaScript can also be used for back end development, making it possible to build full stack applications using a single programming language. Okay, so JavaScript's ecosystem is one of the most vibrant and versatile in modern programming. With its wide array of frameworks, tools, and environments, JavaScript enables full stack development and has become an integral part of the software development process. So, first, its front end frameworks. We have React, Angular, and Vue. Um, JavaScript powers the front end development of modern web applications, and several frameworks enhance its capabilities. First one is React. So, React, developed by Facebook, which is a library for building user interfaces. It uses a component based architecture, allowing developers to reuse code efficiently. So, React is ideal for creating dynamic, high performance single page applications. Second is Angular. Angular is maintained by Google, which is a comprehensive framework that provides tools for building dynamic and scalable applications. It includes features like two-way data binding and dependency injection, making it a great choice for enterprise level applications. Um, Third is Vue. Vue.js is a lightweight, progressive framework that is easy to integrate with existing projects. Um, it is particularly popular among startups and small to medium sized projects due to its simplicity and flexibility. Okay, these are for front end frameworks. Now we'll go to back end frameworks, like back end with Node.js, which is used for server side programming. So um, Node.js is built on Google's V8 JavaScript engine. It provides high performance and scalability. Um, it excels in building real time applications such as chat systems and collaborative tools thanks to its non blocking event driven architecture. With Node.js, JavaScript has become a true full stack language, enabling developers to work on both the client and server side using a single programming language. Okay, third is tools. Tools we can use npm and webpack. Now, JavaScript's ecosystem includes tools that streamline development workflows. So, npm is Node Package Manager. So, Node Package Manager, npm, is the largest software registry in the world, hosting millions of reusable packages. It simplifies the process of managing dependencies and libraries in JavaScript projects. Um, then we have Webpack. Webpack is a popular module bundler that optimize JavaScript code for deployment. It combines multiple files into a single bundle, reducing the load time and improving performance. So the JavaScript ecosystem supports developers to build applications of all sizes, from simple websites to large-scale enterprise systems. The wide range of tools and frameworks ensures flexibility, scalability, and efficiency, and it makes JavaScript an essential language for modern software development. Okay, now we'll go through SQL. SQL, or Structured Query Language, which is a specialized programming language designed for managing and interacting with databases only. It is widely used across industries for data storage, retrieval, and manipulation. So let's see. Um, SQL is a declarative language primarily used to manage relational databases. Unlike procedural programming languages, um, which focus on how to accomplish tasks, SQL emphasizes what needs to be done. For example, instead of detailing every step to retrieve data, you simply specify the desired outcome, and the database engine takes care of the process. So, SQL allows users to retrieve data efficiently from databases using commands like select. For example, you can use SQL to find specific records, such as retrieving all customers who made a purchase in the last month. So it is a simple one line or two line query that you will just write whatever you want, and then the database will do that part. Now we have some commands which we frequently use. So for insert, we use insert. For update, we use update. For delete, we use delete. So these capabilities ensure that databases remain accurate and up to date. We'll also see some examples later. So third is relational data management. So SQL excels in handling relational databases where data is organized into tables with defined relationships. Through operations like join, SQL allows you to combine data from multiple tables, providing a comprehensive view of the information. Okay, now what are the applications? So we can use it on business intelligence, like it is the backbone of business intelligence tools that analyze data for decision making. For example, SQL queries can extract and process large data sets to generate reports and dashboards for organizations. Second is data analysts rely on SQL to manipulate and analyze structured data. SQL enables them to aggregate data, perform calculations, and uncover trends. For example, you might use SQL to calculate the total sales by region or identify patterns in customer behavior. SQL is integral to web applications also, where it powers the back end systems that store and retrieve user data. For instance, e commerce platforms use SQL to manage product catalogs, customer accounts, and order histories. Okay, now we'll see the ecosystem of SQL. Um, Popular databases are MySQL, PostgreSQL, and Oracle SQL. So SQL forms the backbone of various relational database management system (RDBMS), including MySQL, which is an open source database widely used for web applications and small to medium sized systems. It's known for its reliability, and it's is commonly paired with PHP and in LAMP stacks for web development. Then PostgreSQL, which is a powerful open source relational database management system with advanced features like support for JSON and geospatial data. Um, it's a go-to choice for developers building complex applications requiring scalability and custom functionalities. Third is Oracle SQL, which is a part of Oracle's relational database management system, renowned for its enterprise grade capabilities. It offers robust security, high performance, and advanced features like real application clusters, making it ideal for large scale business applications. Now, second, we have cloud based solutions like Amazon RDS, Google Cloud SQL, these things. So, Amazon RDS, Relational Database Service, which allows developers to set up and scale databases in the cloud with minimal administrative overhead. Um, it supports multiple RDBMS engines, um, including MySQL, PostgreSQL, and Oracle. Second is Google Cloud SQL, which is a fully managed relational database service that supports MySQL, PostgreSQL, and SQL Server. It integrates seamlessly with Google Cloud's analytics and AI tools, making it an excellent choice for cloud based data solutions. Third is integration with BI tools like Tableau, Power BI. These are the tools that is being used by data analyst. So to analyze big data or to do analysis and get reports, we use Tableau or Power BI, this kind of software. So SQL is crucial for generating insights and driving business decisions when integrated with business intelligence tools. So Tableau connects to SQL databases and provides a user-friendly interface for creating interactive dashboards and um, visualizations. So it's widely used in business analytics to explore and present data effectively. On the other hand, Power BI, a Microsoft product, integrates seamlessly with SQL Server and other databases. It enables organizations to transform raw data into actionable insights through dynamic reports and dashboards. Okay, now here in recent years, several programming languages have emerged to address modern challenges in software development. These languages are designed to be more efficient, safe, and versatile, often improving on limitations of older languages. Now, let's discuss some of the most prominent emerging languages. First is Swift. Um, it is optimized for iOS development. So Swift is developed by Apple, which is a specifically optimized for creating applications for iOS, Mac OS, Watch OS, and TV OS. It replaced Objective C as Apple's primary development language and was designed for speed, safety, and modern syntax. Swift's simplicity and readability make it beginner friendly while offering the power required for advanced app development. For example, apps like Airbnb and LinkedIn leverage Swift to deliver seamless user experiences on iOS devices. Second is Rust, um, which is focused on safety and concurrency. So Rust is a systems programming language that prioritizes memory safety and concurrency without sacrificing performance. It is particularly effective in preventing common programming errors like null pointer dereferences and buffer overflows. Um, Rust is used for developing performance critical applications such as operating systems, game engines, and web browsers. For instance, Mozilla Servo browser engine is built with Rust. So, its growing popularity stems from its ability to combine the performance of C++ with modern safety features. Next is Kotlin. It is a modern alternative for Java. It is developed by JetBrains, which is a modern programming language designed to be a more expressive and concise alternative to Java. It's fully interoperable with Java, making it easy to integrate into existing projects. Kotlin has become the preferred language for Android development, especially after Google officially endorsed it in 2017. So, developers appreciate Kotlin's null safety features, which help reduce runtime errors, and its concise syntax that reduces like boilerplate code. Last, we have Go. Go means Golang, which is lightweight and scalable. So, Go or Golang was developed by Google to address challenges in building scalable systems. It's known for its simplicity, efficiency, and excellent support for concurrency. Go's lightweight runtime and fast compilation make it ideal for developing web servers, microservers, and distributed systems. Um, Popular projects like Docker and Kubernetes are built with Go, demonstrating its effectiveness in cloud native and containerized environment. Okay, so I already talked about the use cases also for these languages, so I will just go into next slide. Okay, we'll now see some examples, the codes. So here we have an example of Python code like basic automation. So the use case is renaming files in a folder. We want to rename files in a folder. So we will automating file organization in a directory. So we can write this code. We can use import OS and then folder equal to the path of the folder. So for index, file name is enumerate, and then we'll have new name of the file name, and then we'll have that code. So the result will be files are renamed sequentially. So this is how we can just run a simple 5-line code and just rename all the files in a folder. Now next is Java. So basic console application. um, we want to print a greeting message. Now building console based tools for learning or simple tasks, this is the real world application. So we'll just print, we'll say public class hello world and public static void main string arguments and system out print line hello dot hello comma java world. So this is how we are printing, and the results, it will display hello java world in the console. Next we have an example for C++ basic input and output. So asking for user input and printing it. This is the use case. And then simple console tools for gathering information. So we'll have include IO stream, input output stream, then using namespace standard, then integer main, string name. I am guessing that all of my students in this class have at least a basic idea of programming languages, a basic you all know, I'm hoping you all know the basic syntax and semantics for programming language of any of these, like it could be C, C++, Python, Java, any of these. If you have any of these any of one of them of like if you have experience or you learn any of them, then you are good to go. So because the idea or the goal in this course is to uh, learn the theory of the programming, not just focusing on one language. So if you know any of them, that will be good for this course. And if you don't know if anyone don't know any of the languages, or so you're not familiar with programming languages, uh, and you're so I would suggest, I will highly appreciate if you start learning at least one programming language for this course, because otherwise you won't be able to cope up with this course. And if you need any help from me, you can always email me or uh, like knock me to help you. Anyway, so here in this C++ code, we can like have string name C out, then we are printing C out, enter your name, and then C in, we are storing this whatever it's coming from input from keyboard, we are storing it in the name. And then we have C out, we're printing hello, and then name, the variable name we are using, and whatever stored in name it will print. So the result will be greets the user by their input name. If suppose the name is John, it will say hello John. Okay, last we have JavaScript. So setting up a simpler server to return a message, then understanding server side basics. So this is the small example of how you can have this, how you can set up a simple server to return a message. So here you have the result, which displays hello JavaScript world when accessed via a browser. So when you will write this and you will access this with via a browser, it will print hello JavaScript world. That is all for today's class, and I hope you understand all the languages and their history and all the other things. If you have any question, feel free to let me know, and we'll meet on next lecture. Thank you.